In this video, I would like to talk about the syllabus of this class. The title of this class is called Introduction to Parallel Computing. Its precondition course is ITSC 2020 Data Structure and Algorithms. This course introduces students to program in multi-core parallel systems, as well as analyze and tune performance in modern homogeneous or heterogeneous parallel hardware architectures. In this course, we are going to combine theoretical study and practical applications. We will focus on parallel programming by using different techniques, C++ multi-threading, and OpenMP for shared memory programming, MPI for distributed memory programming, and CUDA for GPU programming. This learning map demonstrated the main modules. The module 1 will be about setting up a programming environment and get used to C++, programming, and Linux utilities. And module 2 is about fundamentals in parallel computing. Module 3 will be distributed memory parallelism. And module 4 will be midterm exam. Module 5 will be shared memory parallelism by using C++ multi-threading. And module 6 will be shared memory parallelism by using OpenMP. And module 7 will be heterogeneous shared memory parallelism by using CUDA, the whole thing here. Module 8 will be final exam. In module 3, 5, 6, and 7, we are going to give examples. And also, we'll emphasize parallel program design. So in that case, we cover all. Each module follows the same learning cycle. Every module, same learning cycle. So everybody will need to follow same steps. First, each and every one of you needs to read book chapters. Usually I will give to you, and finish preparation work quiz. Then I will assign the labs to you and give corresponding demonstration video to help you practice different parallel programming techniques, as what we mentioned, C++, multi-threading, OpenMP, MP, and CUDA, right? And in these two, the first two stages, we're encouraging you to form a group and studying groups. And after you finish the first two steps, and then we'll give you programming assignment and the course project timeline. And this is individual work. We would like you to use what we have learned from the books, book chapters, and also the labs, and use what you have learned from the previous two steps to work on a specific problem and solve a problem by using parallel computing techniques. This is the grading scheme. We will have a preparation work quiz for 6 modules. In total, it's worth 10%. And the course project includes 4 timelines. In total, 20%. Each timeline, 5%. And we will have 12 to 13 labs, and a total 20%. Each lab is worth about 1.5 points. And 2 exams will cost 20%. And we will have about 4 mini projects. In total, 20%. And you can imagine each one 5%. Others, including surveys, self-reflections, or active participations, in total 10%. Here, this is one example. So I'm going to show you one spreadsheet. This is a scoring schema. And you can also find this scoring schema in Canvas. I'm going to show you this example. So from this example, you may find out we have scoring schema listed here, and we have each specific item in the details. And in the beginning, everybody, you have 100. Everybody is A in the very beginning. And let's see what corresponds to this 5%, 10%, 20%. Let's say Peter Pan missed one exam, right? Missed one exam. And when it missed one exam, the score is gone. And since it missed one exam and such that the attendance is not perfect, right? This is attendance, and this is attendance is not perfect. Let's just say it's about close to perfect, 98%. So since missed one exam, and this will be the specific points will be cut out, then you can say one grade level down. Now let's say Peter Pan also let's say project, right? Missed the mini project. Let's say it missed 2 mini projects, right? Because it's individual work, maybe a little bit tough. So you can say 2 level down. And we see here, once you finish the book chapters, once you finish the labs and follow what we give you instruction about the labs and solve the problem, in that case, mini projects should be no problem. So if you miss 2 mini projects, it's 1 level down, right? So let's say continue to check. If this Peter Pan miss also timeline, right? Because in the first 2 the labs, the 2 modules, and Peter Pan didn't follow us, such that mini project cannot finish and the timeline cannot finish. So now let's say this is another level down, right? No, you can say from A, drop to grade D. This is not what we want, right? Even even the Peter Pan work very hard on other things, but still, this is corresponding to. Let's say if we miss one lap, right? If we miss one lap, as we mentioned, it's about 1 or 1.5, this kind of right? So you can see it dropped. So every item here, they will cause some specific points. Just make sure with the semester move forward, connect all the points and keep the schedule and don't miss that. Okay. So I'm going to move to the next slides. I'm going to move to the next slides. Now let's take a look how I treat myself, which kind of role I should play in this class. So for myself, I'm here to motivate and lead you to learn the parallel computing. You are here to learn the parallel computing, and my role is to provide positive environment in which you can learn fundamentals in parallel computing, distributed parallelism with MPI, homogeneous shared memory parallelism with C++ multi-threading or OpenMP, heterogeneous shared memory parallelism with CODA. And some students may ask, how can I succeed in this class? And we see the syllabus is the guideline for this course, right? It includes, the objectives for this class, materials, and also tentative schedule. And I believe all the students can study and grow in this course. Since this class is online or synchronous mode, communication is critical for us to learn together. And also, I would like to ask everybody to improve your time management skills and form a good study habits. And go to the slides, click the links. You can find specific materials can help you improve that. For good communication, I encourage you to use campuswell.com, which features PSR plus Discord or Slack. And the PSR and Discord, this is our student lab, right? And so, we would like to use that. I already sent you invite, and please sign up. And if you have question, ask question in the Campuswell. And even if you have the study group, and go to the Campuswell and to organize. For timely text messaging, please everyone needs to sign up the Reminder app. For the instruction, our class code is 3145S2021. Or if you want, you can directly go to this website. Or you use your cell phone, go to the text messaging, tap 81010, and then they will ask you for the code. Then you tap 3145S2021. And for some students may ask for later submission. We see that the final day to submit a late assignment is the day that the results have been posted. And 1 point will be deducted from the final score for each day the assignment is due, right? And then, so one more thing, very important, time management is very important for this online asynchronous class. Please follow our schedule and pace your time. And here are important dates for this semester. First day of class, January 20. And last day to register, add or drop with no grade, January 27th. Last day to withdraw, March 25th, 2021. Last date of the class is May 5th. Final exam beginning on May 7th. So that's all for this video. Thank you.